Welcome to this ocean climate science lesson brought to you by Stay Cool. This is lesson 1, part 1 about ocean warming. And I am Shelji Gangrade. I will be teaching this lesson. I am a graduate student at the Scripps Institution of Oceanography, which is at the UC San Diego. And I'm a second year PhD student, so I'm just getting into my research and I'm on my way to get my degree and I'm having a blast. But I'm super excited to be here teaching all of you. I'm from Delaware and I grew up loving the ocean and making the most of all the beach trips we had back there. I grew up to love marine science. I majored in marine biology and engineering at my university, which is the University of Delaware. And I joined the sailing team. I got to snorkel in New Zealand and I got to go on boat trips and pick up some squishy squid eggs, which you see in this picture here. I got lucky to go on some research vessels, and my journey is continuing here at Scripps as a graduate student doing research on plankton and fish in the California Current, which is just off the coast here. And so let's dive into this lesson and let's start with some guiding questions that we have for this lesson in this part 1. So we're going to ask some questions, and if maybe you have a piece of paper or a notebook next to you, you can maybe answer these questions or think about them a little bit more. We're going to kind of discuss the scientific method here in terms of observing phenomena and creating a hypothesis and predicting what you believe is an answer and experimenting with that and coming to a conclusion from your results. So the first question here, we're going to break down. So the question is, does burning fossil fuels increase the amount of carbon dioxide in the Earth's atmosphere? So remember, this lesson is about ocean warming, but let's take some steps back and let's talk about, okay, burning fossil fuels. You've probably heard it before. Fossil fuels include things like coal, oil, gas. Then we're talking about increasing the amount of carbon dioxide. Well, carbon dioxide is a gas, and you might be familiar with it because it's the gas we breathe out as humans. And it's involved in the Earth's atmosphere, which you may have already discussed before. And we're going to get a little bit more into that. So again, this question is, does burning fossil fuels increase the amount of carbon dioxide in the Earth's atmosphere? All right, well, why does adding more gases like carbon dioxide to our atmosphere make the oceans warmer? So again, this is the ocean warming lesson. So why are we going to discuss that particularly? And then how do we know that the Earth's oceans are getting warmer? And can we measure that? And there are going to be some really cool tools we're going to discuss. But let's go back to this Earth's atmosphere and how carbon dioxide is involved with it. We're going to talk about the greenhouse effect. And carbon dioxide is a greenhouse gas. And these gases, which include carbon dioxide and methane, many other gases, make up the atmosphere. And when radiation from the sun, so heat from the sun comes in, it gets sort of trapped and it's this blanket around the Earth. Well, when we have a lot of those gases and more of them, this effect is intensified. So what that means is increasing how much heat is being trapped around the Earth, and the less heat is able to escape back out into space. So this is why we see regions of the Earth warming, and this is why we talk about a global sense of warming. Well, we talked about atmospheric carbon dioxide as that greenhouse gas, and it's rising. And the question is, how do we know this carbon dioxide, which can be released from burning fossil fuels, is increasing in the air? So we have a picture here of factory and car emissions releasing carbon dioxide. And so how do we know this? Well, we measure it. So scientists like me, students like me, at my institution specifically, we have had the Keeling family, father and son, both scientists at the Scripps Institution of Oceanography, have led the charge in documenting this increase of carbon dioxide. So we have this observatory in Mauna Loa, so in Hawaii. And if you look at this graph, we have time on the horizontal on this bottom axis. And we see it all the way back from before the 1960s to 2020, to today, to this year. And we see carbon dioxide on this vertical axis. And we want to discuss this increase, this rapid increase of carbon dioxide in the atmosphere over time. And it's pretty stark, like it's pretty intense, right? Well, what are these wiggles? We see these kind of zigzagging shapes. Well, within 1 year itself, we see variations in carbon dioxide. We have different seasons during which carbon dioxide is actually less. We have lots of trees, lots of plants blooming, and they are going to suck up some carbon dioxide. So we see a little decrease and then it goes back up. So that's what we call just the annual variation, the seasonal variation in carbon dioxide. But what we want to focus on is this long-term increase shown by this curve, which we call the Keeling curve, named after the scientists who began this series of measurements. So that's pretty cool that we have this record. Now let's zoom out. Let's look at the Earth and let's ask ourselves, why is the Earth called the blue planet? You've seen documentaries name that. You've seen a lot of people toss around that term. But can you guess what percent of the Earth is covered with water? We can take a look here. You might have heard this number before. And it's because 70%, so that's more than 2/3 of the Earth, is covered with water. And so we're going to focus on the oceans here. And this is why this discussion is so important. The ocean is massive and it's deep, and there are many ecosystems at play here. So when we talk about the distribution of heat, it's going to be affecting a lot of the Earth in terms of the oceans. And so we talked about this heat coming out of this greenhouse gas effect. We talked about how it's intensifying, global warming. So we have excess heat. Where is it going? So if we look at this graph here, we see this red kind of chunk on the graph talking about heating on land, in the atmosphere, and some ice. In the blue chunk, we're talking about heating of the ocean. We can see that over time, which is on the bottom here, we see that the red chunk's getting a little bit bigger, right? So we're going to see the blue chunk also get bigger, but quite a bit, right? So the idea here is to answer this question is over 93% of that excess heat is going to the oceans. So most of that excess heat is going to the oceans, whereas 7% of that heat is going to the land and the atmosphere and the ice, which is also important. But what we're talking about is this massive amount of heat being absorbed by the oceans. And okay, so we just talked about that heat being absorbed, but how do we know that the oceans are then actually getting warmer? Well, again, we measure it. So scientists have developed various methods, and since the late 1700s, people have gone out on ships or piers or just beaches and used simple thermometers and get buckets of water and been measuring temperature. And we, over time, have developed more sophisticated methods. And actually, since 2000, there have been this network of floating robots called Argo to measure temperature almost automatically once they're sent out. So let's show you kind of the spread of all the measurements we get from these Argo floats. So this is a picture of the world and showing you about almost 4,000 floats all across the world's oceans. So not only are we seeing temperatures rise or change, we can see it in different parts of the world. And that's really important to get a whole view of the situation. All right, so how does that Argo float work? And well, hopefully we will talk more about it in detail and we can showcase an actual float for you. But for now, let me just discuss more simply how it works and some components. And so these are floats, like it says, moving about in the ocean, gathering and transmitting data. So the data is what we want. So we put these floats out, they descend down, and once they reach a depth, sometimes as deep as 2,000 meters, they then slowly ascend and slowly come up. While they're coming up, they're measuring temperature, for instance, or salinity, which is the amount of salts dissolved in the water. And as they're coming up, they're getting this profile, as we call it, with depth. What does temperature look like? Then it ascends all the way to the surface, and we ping this information to satellites that receive it on land. So we're getting the ocean, we're getting the data all the way from the ocean. And this whole cycle takes 10 days. And so people put these robots out there, and they kind of are programmed to work on their own. And so that's why we kind of call them robots. And so if we take a little bit of closer look, they're made up of various parts that let them do this cycle, this descending, this ascending, taking measurements, and transmitting data, which is all very crucial to the process. And so there are things like satellite antenna from the top that transmit data. There are computer components. There's a battery to make sure it's able to do what it does for that long. And there's this hydraulic system that allows it to descend and ascend, so go down in the water and come up appropriately. And hopefully, like I said, we can discuss this a little bit more in a future lesson. So these Argo floats are measuring temperature for us across the world. They're one of many sets of measurements happening across the world by scientists. And it's wonderful to hear about this because a lot of scientists at my institution, at Scripps Institution of Oceanography, are part of these projects with the Argo floats. And students every day like me are coming up with really cool questions to ask with all of this data from around 4,000 floats across the world. So back to the ocean warming trend. Sea surface temperatures, so the temperature of the water at the surface of the ocean, over the last about 100 years, 100 plus years, is shown in this graph here. So we see about from the 1900s on to around 2020 today. Look at this orange line. We see an increasing trend. We see this increase over time, over 100 plus years. But we also see these blue and these red. So these blue and these red. And so that is showing you variations that at times, okay, it's blue, it's below zero. So the temperature change was actually cooling in the sea surface. And the red, it was increasing and it was warming. So we have these variations, but what's important is when we're looking at this orange line, this average trend, is we see an increase. And on this graph, it shows you an increase about 0.092 degrees Fahrenheit per decade, so per 10 years. And you're like, okay, 0.09. That doesn't seem like a lot. Between night and day, we get maybe a 10 to 20 temperature decrease, but 0.09 over a decade, well, the change is gradual. It takes time and it's slow, but it matters. It matters, and we've seen it. We've seen it affect ecosystems, which you are definitely going to learn about in the next lesson. And so this is also important, just discussing this trend, variations, and an average to get a better idea. Okay, so let's summarize. We've talked a lot about ocean warming here, but fact number one, burning fossil fuels releases carbon dioxide, as we discussed, into the Earth's atmosphere. And atmospheric CO2, as we've measured, has been rising each year, and we've seen that through the Keeling curve. Fact two, excess heat is being trapped in the oceans, and The oceans, we said, suck up that 93% of that excess heat, and that's why we care so much. And then lastly, fact 3, scientists are measuring this change, and we measure how much the Earth's oceans are warming using things like Argo floats. And this data we obtained is showing this gradual but significant increase. And we're going to discuss later how this is really going to affect organisms in the ocean. So with that, I'm going to end this lecture, and hopefully you guys have some awesome questions, and hopefully you can get some answers. Please reach out to your teacher or reach out to us here at Stay Cool if you want some more information. Thanks for joining me. Again, my name is Shelja. You guys can call me Shelly, and it was great giving this lesson to you today. Thanks so much. Have a good one.